Why is 0 factorial equal to 1? Now we're going to look at this problem at 3 different levels of cleverness, from simple level to frost level. And in case you don't know what factorials are, 4 factorial, written as 4 exclamation mark, means that number 4 multiplied by 1 less, then by 1 less again, until you get down to 1. So that's going to be 24. But it seems weird to ask what 0 factorial is, because if you start at 0 and multiply by 1 less each time until you get to 1, well, we're already below 1. So how could we work that out? Now, the first level of simpleness, level 1 of 3, is to think about powers. Now, we know what 2 to the power of 3 means. It means you multiply 3 2's together. But what does it mean to have 2 to the power of 0? How can you multiply 0 2's together? Well, let's look at the pattern with powers. Now, 2 to the power of 3 means 2 times 2 times 2, which is 8. 2 squared means 2 times 2, which is 4. And can you see that these indices are going down by 1 each time? And each time the index goes down by 1, the result becomes 2 times smaller. So divide by 2, divide by 2, and if we divide by 2 again, 2 divided by 2 is equal to 1. So anything to the power of 0, except for 0 to the power of 0, which is a different story, is going to be 1. And we can use the same principle of kind of following this pattern with factorials. So 4 factorial is 4 times 3 times 2 times 1. And when we go down to 3 factorial, we can see we no longer have this 4 in the next line. So it's going to get 4 times smaller. And then from 6 to 2, it's going to get 3 times smaller. Then 2 to 1, it's going to get 2 times smaller. And if we follow this pattern, we think we're now going to divide by 1. And 1 divided by 1 is 1. So 0 factorial is 1. Another way of thinking about it is if you started with 4 factorial, which is 4 times 3 times 2 times 1. Now, this 3 times 2 times 1 here could itself be written as 3 factorial. That's what's meant by 3 factorial. And more generally, when we work out n factorial, it is n multiplied by n minus 1 factorial. So if we were to consider 1 factorial, that's going to be equal to 1 multiplied by 0 factorial. But we know that 1 factorial is 1. So we've got 1 equals 1 times 0 factorial. Then 0 factorial is equal to 1 divided by 1, which you can see is equal to 1. But this seems a bit of a cheat because we're basically just assuming we can follow this pattern to go down to 0 factorial. So for this next level cleverness, level 2 of 3, we're going to think about why this result of 0 factorial equals 1 is useful in other parts of mathematics. So we're going to look at something called the choose function. And what the choose function is how many ways of picking a certain number of things out of a larger group. And this is the formula for it here. So n choose r, we say as, is equal to n factorial over r factorial, n minus r factorial. So let's say you've got 5 friends and you want to choose 3 of those 5 friends to come to your party. How many ways of doing it? Well, we're working out 5 choose 3. How many ways of choosing 3 things from 5? So we said the top number on the left was the n, and the smaller number was the r. Now, if we use the formula above, it's n factorial, so 5 factorial, over r factorial, so 3 factorial, and then times by n minus r factorial, so 5 minus 3 factorial, which is 2 factorial. And if you work that out, 5 factorial is 120, 3 factorial is 6, and 2 factorial is equal to 2, and that gives you 120 over 12, which is 10. So there's 10 ways of picking 3 of your 5 friends to come to your party. But what about if we said, how many ways of choosing 5 of your 5 friends to come to your party? Well, there's just one way, right? If you've got to pick all of your 5 friends, there's only one way of doing that. So we expect this answer to be 1. So we're finding 5 choose 5, the number of ways of picking 5 people from 5. Now, here the n is 5 and the r is 5. So if we use the formula again, it was n factorial, 5 factorial, over r factorial, which is 5 factorial, multiplied by n minus r factorial. So 5 minus 5, which is 0 factorial, like that. Now we can see the 5 factorials cancel. We can just divide top and bottom by 5 factorial to just give 1. So we end up with 1 over 0 factorial. But we know the result should be 1 because there's one way of picking 5 friends from 5. And that would mean that this 0 factorial would have to be 1. So we can see it works in practice. Now, finally, level 3 out of 3 of cleverness is to think about how we can extend the factorial function to decimals and negative numbers and even complex and imaginary numbers, things like I, if you might have heard of that. And we have something called the gamma function, which is here, that's the Greek letter gamma, and that's the analytic continuation of the factorial function. What analytic continuation means is to take a function, like the factorial function, and extend it to work for a wider domain of numbers, like negatives, decimals, complex and imaginary numbers, for example. And this is the formula to work it out. It uses something called integration. Now, the gamma function basically is offset from the factorial function by 1. So, for example, if you wanted to work out the gamma of 4, then that would be equal to 3 factorial, so just 1 less factorial. And the gamma function is great because it allows us to find like fractional numbers factorial. We know, for example, that 3 factorial is 6 and 4 factorial is 24. So you might wonder what 3.5 factorial is. It's going to be somewhere between 6 and 24. And you can see it on this graph. Now, if we use this particular function here, gamma of z, well, we want to try and find 0 factorial. So as we said, it's offset from the gamma function by 1. So we're going to find gamma of 1. And if we use this formula up here, we're going to do the integral between 0 and infinity of t to the power of z minus 1. Well, z here is 1. So t to the power of 1 minus 1, e to the minus t dt. So if we simplify that, 1 minus 1 is 0. So we get t to the power of 0. Anything to the power of 0 is 1. So we're just left with e to the minus t dt. Now, this is known as an improper integral because we're integrating to infinity here. So what we do is we write it as a limit. The limit as, let's say, k tends towards infinity of this integral from 0 to k. And the reason we're doing this is because we're not allowed to substitute in infinity. So now we can work out this integral. Well, e to the minus t integrates to minus e to the minus t, and we're integrating between 0 and k. And if we work this out, we're going to get minus e to the minus k, subtract negative e to the minus 0, like that. Let's just simplify further. We get minus e to the minus k, and e to 0 is 1, so we get plus 1 here. And we could write that negative power there using a reciprocal. So we could write this as 1 minus 1 over e to the k. Now, can you see that if k is tending towards infinity, we're going to have 1 divided by e to the power of infinity, 1 divided by a very large number, and that term effectively becomes 0. So we're just going to be left with the 1, and we've therefore proven that 0 factorial is equal to 1.